Cool. So you should be able to see that there on your side. Is it recording? Should be.
Yeah.
Yes, it is. Awesome. Okay. So you can see it?
Yep.
You can see fine. All right. So the first thing I want to talk about is just this list that I've created for just the achieved. So organic can be challenging in a sense that it doesn't have nice categories of questions as thermochemistry does, and you can't rote learn it. It is a really steep learning curve to understand organic. However, I went through the last 3 past exams, and I've gone through the marking schedules and made a to-do list of all the things they need for achieved, and I'm going to show you guys how you can take that and still understand what these questions are asking, because that's the biggest challenge with organic chemistry, is understanding what they're actually asking for. So the 3 points that I had here is that the first thing you need to be able to do is identify your functional groups. The reason why is because you're going to be reading a lot of these questions and they're going to be referring to these functional groups, or they'll give you formulas and you're going to have to know what the functional group is. So that way you know how to convert it and what properties it has. So that's the first thing you got to do. That one I've linked here on this Quizlet, which has all the different like functional groups with their various kind of what they look like and some description of it. So those are all there. What did I want to say about that? I think that's it. It's stuff that you guys did with spec. So it's not the end of the world. You should hopefully have some idea of what these different functional groups are based off of what we did with spec. The second thing you're probably going to need to be able to do is name and draw. Just again, so generically you know what they're referring to and what sort of properties you're looking for. And then the last thing is your identification tests and your conversion tests. The good news is that a lot of the identification tests will overlap with the, what's the word I'm looking for, with the conversion tests. So you'll see they're actually one of the same. So to help you guys memorize it, I have a couple different flashcards. I have this one here. I think they're just basically different versions of the same thing. And I also have this version over here as well. I'm pretty sure they're the same, but just different ways I've described it. So like, for example, knowing what bromine water does. And bromine water is a way to convert an alkene to a dibromo. So again, this is what I'm saying, why you need to know your functional groups, because you need to know what that means. Okay? So an alkene is an alkene is a carbon molecule, a hydrocarbon molecule, so hydrogen and carbon, but it has a double bond. And in this case, the bromine that's being formed, the dibromo alkene, is we're breaking the double bond and adding bromine. That's our haloalkane. This is what I'm saying. You need to know your functional groups because that's kind of the foundation stuff. The other thing is then knowing your color changes, so going from orange to colorless. The other thing that would be useful to know this is also like what type of reaction it is. So that's an addition reaction because we're adding to the molecule. Substitution is you're just swapping one thing for another. And then elimination is taking stuff away from the molecule. And then you might also have oxidation as well. So those sort of things you just need a baseline kind of memorize. In order to, again, help you, and this is why I'm opening it up so we can refer to this when we look at the exam, is these flashcards here. So these flashcards here are all about identification, I believe. What does it say? Yeah, so these are the identification flashcards. So if you have these memorized, you'll be able to decode what the question's saying. Same thing with this guy here. These are the conversion flashcards. So you don't need to memorize the flow chart. You do need to understand what each one of these things are for. So you should know if I want to go from an alkene to a haloalkane, then I need Br2Cl2 with UV light. And so what that's going to do is that's going to substitute out one of the hydrogens for a halogen. And that's why it's called a substitution. So these flashcards are really, really useful. If you can learn those things, then you should be enough to pass. All right, so let's actually take the stuff that we've talked about here and decode it onto the exam. The other thing that I've done that I've already scanned on to Google Classroom is I have a list of stuff. So there's some other things that you can just learn as base foundations to get the achieved, so that way you can still get your points. Okay? Cool. Feel free to stop me whenever you need to. So I will be referencing the marking schedule and I will be referencing the exam, so that way we can see what is the bare minimum we need to do. Oh my goodness. So let's go to this piece of paper now. So I will be going back and referencing those things there. Where else I did? So this is the 2023 one. All right, so here's my first question here. I'm trying to spot to drop my paper. So this one here has 2-hydroxybutanoic acid, and it tells me that it can exist as enantiomers. So one of the things that I've written down here that you need to know is some of your vocabulary. So we need to know what the word enantiomers mean. It also means optical isomers. All right? So they've given me the molecule here. All they want you to do is to circle and describe the structural feature that enables the 2-hydroxybutanoic acid to exist as enantiomers. Okay? So again, we just need to know our definitions for that one, for that achieved one. So first thing we need to look for is we are looking for what is called a chirocarbon. That is a carbon that has 4 different things attached to it. So what you need to do is you go through each one of these and ask yourself, is there 4 different things attached to it, or is there not? So look at this first carbon here. You see how there's 3 hydrogens. So that one's not chiral. So I'm crossing that one out. This one over here, it has 2 hydrogens. So that's a repeat. So I'm crossing that one out. All right. This one over here, I see it has the ethyl branch. So it has this one as its first option. Second option is it has an alcohol. Third option is it has a carboxylic acid. And then fourth option, it has that hydrogen there. So that's 1, 2, 3, 4 different things. So that is an example of a chirocarbon. So we need to be able to know our definitions. So for an enantiomer to form, we need a chirocarbon. Chirocarbon means 4 different things attached to it. So that's just memorization there. So chirocarbon needs to have 4 different things attached. Okay? So I've identified that one as that, so I'm going to circle it. Okay. And then when I look at this last carbon here, it has a double bond to oxygen, because this here, the COOH, is a shorthand to refer to carboxylic acid. So again, this is what I'm referring to when you need to memorize stuff. So, yep, go for it.
Are we allowed to, sometimes draw it out?
Yeah, you're welcome to do that. So this one here, I see how this carbon has a double bonded oxygen, so that doesn't have 4 things. So that one's out. So the right answer is that carbon here.
So basically, this is just like ruling them out.
Yeah. So all you're doing is you're going through the molecule and you're going, which one of these carbons have 4 different things attached to it? Because I'm looking for a chirocarbon. So you can memorize that word and then you just apply it. Yes, question. Or where you keep on.
Just writing that sentence will give you an achievement.
So let me walk you through it. So what they're looking for the achieved in this question is a little bit more than what I would expect. I'm not happy with some of this stuff. So one of the things that I've noticed over the last couple of years, unfortunately for you guys, is that there has been creeping up of questions. So stuff that used to be an excellence is now a merit. Stuff that was a merit is now an achieved. So they made the exam a lot harder. So it's still manageable. Don't worry, I'm still going to show you how to do it. But if you look at like older exam papers, it's not as painful. But you're right. The first thing that we need to do for the achieved, and that's why I wanted to give you guys the marking schedule, is you see here for the achieved requirement, it says circle correct structure, describe asymmetric carbon, which you have done. Usually, back in the day, that would be enough for an achieved, but now they have an and. Right? So what they want you to recognize is that it has a tetrahedral arrangement. Now, when we're talking about tetrahedral, tetra, if you guys remember with your organic naming, means 4. So what they're just trying to ask you is, do you recognize there's 4 things attached to that carbon? And that you've drawn it in like some sort of way. So you can draw it as one way. You could also just write it. And that could be a way to get around it. Because I know that this is something that, is something that can be learned if you want. This one is actually, out of the merit points, not too bad to get, because all you need to draw is draw this guy and then mirror it. And that's more or less, hopefully, straightforward. But if you can't draw this, then you're fine just to write that down. The other thing is, if you draw this and you draw this incorrectly, you can still get the point for it, because all it wants you to do is recognize there's a tetrahedral shape. So for example, when you're starting to draw, you can be like, okay, I know I have this carbon here, and I know I have to have, 4 things attached to it. Like that. To show the 3-dimensional space there. So you have 1 that's a bold, 1 that's a dash, and then 2 that are straight lines. Yeah. And that is going to be a way for an examiner to go, oh, you recognize this as a tetrahedral shape. If you want to take it one step further, all you're doing is you're taking this carbon over here, and you're copying down the stuff that's here onto here. It doesn't matter where you place them. So like this one's a hydrogen. Let's say I put the hydrogen here. This one's my carboxylic acid. Let's say I put that over here. This one's my alcohol. Let's say I put it down here. This one's my ethyl. Let's say I put that over there. So that's also correct. But what you're trying to express in this diagram is that there's a tetrahedral. So that's the important thing. Okay, and that's enough for the achieved. All right, now I'm going to keep track of all the points that we're doing because that way we can see how we're going to go for that question. There is going to be some points that I'm going to go skip the question because it's going to be way too hard. Okay? Just aiming for an achieved. All right, so that's our first one. All right, keep going. We're right with that. So this is an example of some of the stuff that you have to do in order to what was I going to ask? Sorry. Some of the stuff that you have to memorize. And then you can apply the other stuff that we're talking about from the flashcards. Okay. Next one here is we have devise a reaction scheme to convert pentan-2-on to pentanal ethanoate. And then they're like, tell me the reagents and the conditions and tell me the structural formulas. And that can be really scary and overwhelming. Hey, what's up? Not me, because I'm not a year 10 dean. No idea. I don't think she's I don't think she has a coffee alcohol. Try SLT or the front office, maybe. Yeah. So this is a very intimidating question, right? And then there's all this blank paper. So if you look at it, you're like, I don't know what I'm doing. I don't want you to just shut down and stop. Okay, there's a way we can tackle this. The first thing we're going to do when we're thinking about how to tackle this is we are going to note what function groups are here to help us get started. So first thing, pentan-2-on. So this is what I'm saying that you need to know your definitions. You need to know what function group that is. So the on ending tells us ketone. And the other thing is that the pent tells us 5. Okay? When I see pentyl ethanoate, I see over here the O8 tells me ester. All right? Pentyl tells me 5. F tells me 2. Okay? If you know how to name your esters, you will be able to know how to translate that across. So that's why I'm saying the naming and the drawing is important in order to get the achieve, because it's obviously going to apply to things like this because you need to know what that means. All right? So when we're looking at this marking schedule here, this is obviously the full answer, and that's really intense because they're talking about all these steps here, and you have to understand each one of the steps. But when we look at the achieved here, it just says 1 correct conversion in the scheme with reagent. And recognizes that the position of the function group must change or makes an attempt at changing it. So that's all you need to do for the achieved. So let's draw out this first molecule to have a look at it. Let's draw out the second molecule, and we can then think about, okay, what are the steps I can show? So it doesn't matter which step it is. Any of these steps in the scheme can work. But the problem that I find most students have is that if you don't it's really hard to get from this step to this step, conceptually, and that's why that's an excellence. So when we're thinking about the one step, I want us to think either the first step or the last step, because that one you can get from the hints provided. So we're thinking first or last when we're looking at those questions. Okay, so let's draw out the pent-2-on. So pent 2 on would be 1, 2, 3, 4, 5 carbons. Okay. The on tells me carbonyl, and the 2 tells me it's on carbon number 2. Now, it's your choice how you want to number it. You can number it left to right or right to left, but however you number it, you need to number it once. So I'm going to put it over here. Actually, I'm going to put it over here because I like it on that side for some reason. My brain likes it there. So I go 1, 2, that's pent and 2 on. Last thing you then do is you fill in your hydrogens because everything needs to add to 4 for these carbons. Shiga, you okay? You just gave me a look.
Yes, no, sorry. I just looked at the wrong side.
Okay. So yeah, I'm putting mine over here just because aesthetically I like it better there. My brain just likes it there. It just looks, it likes it. It likes it. All right. It doesn't matter though, because if you put it here or here, it's still carbon 2. You just got to commit to it. So the next thing we do is we put in our hydrogens. So remember, you need to have 4 things attached to it. So that carbon is attached to that carbon plus 3 hydrogens. That's 4. This carbon's attached to that carbon and that carbon, so you only need 2. That one only needs 2. That one has 1, 2, 3, 4, so that one's fine. And then this one, I'm just going to make it so that way it doesn't look like it's free floating. And that's 3 as well. Okay? So I'm just drawing out my 2 molecules so I can think about what I have here. The other thing, so I would draw this at the beginning, and I would draw the other one at the end. So that way I can think about this first step or the last step. So pentanol, ethanoate. What I got to be mindful of with esters is that there's 2 sides to it. There's the carboxylic acid side, and then there's the alcohol side. This has come from the carboxylic acid side. And this has come from the alcohol side.
And then
I can't spell either. So, as long as you can look at it and go, that's alcohol in your brain, then it's fine. Okay. So what I'm going to do is I'm going to draw out my 5 carbon. 1, 2, 3, 4, 5. I'm drawing him on the bottom. Okay. Now, if I'm talking about the carboxylic acid component, it has a double bonded oxygen. It has, now I'm thinking about the ester. For an ester to occur, I need a double bonded oxygen. I need a single bonded oxygen. So now I'm starting to draw my ester here. And then I see that it says ethanoate, so F tells me 2. So this is the alcohol component. So that means that there's only 2 carbons after there. Yeah, and whichever way you want to draw it. Like, it means the same thing. Mm-hmm. Okay? Fill in the hydrogens. Okay? Mm-hmm. Both ways are correct. So if you notice,
they only have 1.
No, they have 2. 1, 2. So this is 2. Oh wait, what are they doing? Pentanoate. Did my brain make it the wrong way around? What are you doing? 1, 2, 3, 4, 5. Oh yeah, I'm wrong. I'm sorry, guys.
Oh, I thought they were wrong.
No, we're wrong. That's okay. We'll just cross it out. My brain got excited and thought it was doing something, and then it was wrong. It's okay. Now you learn, because then you know not to make that mistake anymore. Okay. Sorry, the pentyl is the alcohol. I got this the wrong way around. I'm going to blame the baby brain. That one's the carboxylic acid. Just swapping it around. You guys can redraw it. You can fix it now.
That basically be the same.
It is, but you swap where things are. So this is going to be 1, 2, 3, 4, 5, single bonded oxygen, and then C double bond O, C. brain was like, are you doing it right? Yes, you are. Do you see what I'm saying?
Yep. I don't get it, miss.
Don't get it?
Where's the ethane? Where's the ethane?
This here, 1, 2, 3, 4, 5, that is the pentanol. That's the alcohol from the pentyl. And then this here, CCH3, that's your ethanoic acid, ethanoate.
Okay.
Okay?
Oh, I see.
Yep. Good catch. Good catch. All right, we okay with that? Okay. So now that I know the beginning and the end, there's some things I can start working on, because if I have my reactions memorized, then I can actually unpack some of these steps. We can just unpack the first step or the last step and we'll be okay. Okay? Yeah, good. So what I want to then look at, is that even open? Okay, so we go back to here. Let's go through our flashcards. There should be something about esters that makes the ester. Let's see, aldehyde, ketone. Do they have esters? There's an ester here. I'm looking for ester as a product. So what are these? Are these the identification tests or these are conversions? These are the conversions, aren't they? Ah! Okay, we might have to just work around it in a slightly different way, but that's okay. Yeah, these are the conversions. Let's try to see if there's another one with the esters being formed with the carboxylic acids. Oh, here we go. So this one here, you see how it says ester is the product? And then if I backtrack, we need an alcohol, and the other component I need is going to be a carboxylic acid as well. And in order to do that conversion, I need to have heat with concentrated sulfuric acid to allow that to occur. So if I have this memorized, I then know how to do this last step here. Do you want me to backtrack again?
How did you know it was alcohol and not carboxylic acid?
It's both. So this is an ester. That's my final product. So I'm going back flashcards, and I'm looking to the word ester, and I want it after the arrow because it tells me it's producing the ester. So if I backtrack, it says you then need an alcohol, and the other reagent you're going to need is a carboxylic acid and concentrated sulfuric acid with heat.
I thought that C was for like a shorter way for concentrated.
Yeah, concentrated. That's what it means. Conc.
No, that C.
That's the carboxylic acid. Yeah.
Oh, the acid is carboxylic
Yeah.
acid.
Yeah. I normally just write Ca. That's how you guys are used to be seeing it. So, but you see how there I can find the two reagents I need. I need a carboxylic acid and I need alcohol.
Okay.
So when I'm then looking at this question here, I can write that down. So if I backtrack this, I know that this here must be an alcohol, and it's 1, 2, 3, 4, 5. What's that? 1, 2, 3, 4.
Is there a reason why writing it small?
No.
Okay, I understand.
I didn't-
I thought they could need extra space for a reason.
I mean, well, yeah, because I'm going to have to put the ethanoic acid over here too. But you see how I'm backtracking and I'm figuring, okay, this bit here, this is my alcohol, and I've drawn it over here. Because I'm trying to break apart this molecule. It's just like ester hydrolysis, because we were covering that. Yeah? So that's 5. All right? The other thing I'll need is this guy over here, which is my carboxylic acid. You can draw it that way. You can also draw it like you can draw it this way too. Like all of these are correct ways to draw it. I'm just showing you variations of the same thing. So you just pick one. Okay? These are just other ways to write it.
So that's why here's my alcohol and this is the carboxylic acid.
Yeah. Okay? Cool. So I need to put these two things together to make this guy. So that's what we're doing the arrow.
You don't have to write why, like you go concentrate H2SO4.
So I am, that's what I'm doing. So if I draw the arrow here, then I can state that I need conc H2SO4 with heat. And you see how in this case then, you see one correct conversion? We've gotten one correct conversion. Now, again, this is something that is a recent thing that I don't agree with, but now they say you need to also recognize that you need to change the function group or makes an attempt at it, which I was like, what are you doing? So that's why I want to talk about the beginning step here. You see how this is a ketone? Yeah? If we look at our flashcards, there is nothing, or there is one thing that starts with a ketone, but ketones are very unreactive. So I'm looking for the word ketone. I think it might be somewhere here. Here, there you go, ketone. So you see ketone goes here to a secondary alcohol. So I can actually do the first step here as well, because I just had this memorized. Okay? So let's do that first step. So if I was to undo that, I would have an alcohol. Fly. Okay? So again, we got to memorize our reagents. So in this case, in order to do a ketone to an alcohol, you're going to need NABH4, which I cannot remember what that stands for. I should really learn that word.
So when we point that out, then we'll just write down.
Yeah, so you write that on the next side to it. So that way, oh, sorry, the docking camera. So that way you're indicating this is the reagent I need. Because if you see here, it says reagents and conditions. So when we say conditions, we need heat, and we need to concentrate it. Reagents is what you're using. So this one here, sulfuric acid here. Okay?
Question.
Yeah.
For the, like, how we wrote this, if you know in the back of these, usually you get the, periodic table. If you write that instead of writing the, like, sulfuric acid here,
Yeah.
you just write the literal word sulfuric
You would also get the point, yeah. So if you write sulfuric acid, that's fine too. Yeah. Okay? We would write that so far. So this is an example of another step. So we have two steps actually right now. You can do the first one or you can do the last one. It's up to you. The other thing that is about the achieve, which I don't really appreciate as a question, but I'm pointing it out to you guys, is you see how this alcohol is on carbon number 2, but this alcohol is on carbon number 1. So one of the other things you need to do for achieved is just recognizing you need to move the alcohol. You don't actually have to move it for the achieved and figure out how to do that. You just got to know that you need to do that. Can we backtrack?
No. Okay.
I can backtrack. That's why I'm saying I think these exams have gotten a lot harder over the last couple of years. So all I need to be able to state is that I recognize my carbons on number 2, but for this last reaction here, I need it on carbon number 3. Or sorry, carbon number 1. So I need to move it. You don't have to worry about how to move it because that's now the merit and excellence points. Ignore that. Just try to pass. And that's it for that question. And then that would get you another achieve point. Okay. Keep going. All right. Cool. So again, lots and lots of words, but we're not going to let the words freak us out, okay? We're going to go through and we're going to annotate what we know from each of the different molecules, and then we're going to check against what we have here, because this is all memorized, because it's all about identification. All right. So up here, we see how we have a C double bond O, right there. We also see how we have this bit here. Now, is the carbonyl and the amine attached to the same carbon? They're two separate ones, right? So it's not an amide. This is our amine. And then this is a ketone. So it has two functional groups. Okay? Okay. This one we see a carbonyl. This we see an OH, but they're not attached to the same carbon, so they're not a carboxylic acid. So this here again is a ketone. And this OH is an alcohol. And what we need to be mindful of, it's useful to note if it's primary, secondary, or tertiary. So you see how this carbon here, this alcohol here is attached to this carbon, and this carbon is attached to 1, 2, 3. So it's a tertiary alcohol. Okay. This one here, we have a carbonyl, but it's attached to carbon number 1. So it's no longer a ketone, it is now a aldehyde. And then what about this guy? Amine again. So you need to know your functional groups. All right, looking at number 4, we see a double bonded double bonded carbons. So what is that?
Okay.
Good. And then this one over here, you see a double bond, you see a carbonyl and a alcohol, both attached to the same carbon. So what function group is that one? Yeah, good. Okay. This one over here, we have an OH, and then we have a carbonyl, but they're not on the same carbon. So this is now alcohol. Is the alcohol primary, secondary, or tertiary?
Secondary.
Yeah. All right, and then this here is a
Ketone.
ketone again. Okay. Last one over here, alkene. And then this, carboxylic acid. Cool. All right, so now we're going to be looking at this question here, and again, it's just reading and knowing our reaction. So this is our identification test. So this tells us a lot of different things. The first thing it tells us is that bubbles form upon the addition of sodium carbonate in solution. So if we have our flashcards memorized, now we're looking at an identification test. We are looking for things that have the word bubble in it. Let's see. Bubble, bubble, bubble. Or we're looking for the word sodium carbonate is the other one we're looking for. That one's a litmus paper 1. That's another litmus paper question. There we go. React with sodium bicarbonate or sodium carbonate, a solid or in solution, and produces gas bubbles. So that tells me it's carboxylic acid. So this first thing tells me here it's carboxylic acid. Okay. Next thing it tells me is the purple solution goes brown on the addition of potassium permanganate. So I need to look where potassium permanganate is and know what that tests for. So potassium permanganate, here it is. The potassium permanganate turns from purple to brown, and that is to show alkenes. So that's how we know we have an alkene here. Now that can be used for other tests as well, because it should also be able to test for an alcohol. See? So it also can be used for alcohol, aldehydes. It can mean a lot of things. But that's okay. We're going to look at all the information and figure out which one it matches to, okay? So it could be an aldehyde. It could have an alcohol. And it needs to be primary or secondary for that to happen. And the last thing then, it tells me it's soluble in water. So soluble in water means that it's short. Okay? So what I'm going to be looking through is I'm going to go through 1 through 6, and what I'm looking for is which one fits all those categories. So first one here, number 1, no carboxylic acid here. So that rules out number 1. Number 2, again, no carboxylic acid, that rules it out. 3, no carboxylic acid. 4, has a carboxylic acid. So maybe it's number 4. So this is one of our, maybes. Number 5, no carboxylic acid. Number 6, carboxylic acid. So these 2 are my maybes right now. All right? And if I want, I can write 4 and 6 right now and then process elimination and figure out which one it is. All right, the next thing it says is that it needs to be able to react with the potassium permanganate. So either an alkene, aldehyde, or an alcohol, primary, secondary. Again, I run into a problem. You see how they both have alkenes. So I'm not using that hint to distinguish between the 2. The next thing it says it's soluble in water. This one is got this long chain in the middle here. This one's the shorter one. So that tells me that we're ruling out number 4, and the answer must be number 6. Okay? Good news. You've gotten your achieve point. Figure out one compound correctly. They give you 2 chances, so take 2 guesses. You don't get extra achieve points, but it gives you a backup in case you made a mistake. All right, so let's look at the second one here. I'm going to change colors so we can actually have fun. All right, turns litmus paper blue. So if I look over here on the list and I look for my litmus paper turning blue, then it's going to be amine. So that's that hint there. I might do a different color because I didn't turn up too well. I don't know if you can see that one any better. A little bit. Okay. The second thing it says, blue solution to red-orange when heated with Fellings agent. So we need to know what Fellings reagent does. So go back. This is why I say you got to have these memorized. So we're looking for Fellings, and it's going to go blue to orange. Here we go. Gives a red-orange precipitate when Benedict's or Fellings is used, and those are both blue. So blue to orange. So that tells me aldehyde. That's my next hint. Okay? And soluble in water, so that tells me short. So again, when I go through here, I'm trying to find one that has both of those properties, or sorry, all 3 of those properties. So number 1 has an amine but no aldehyde. That one's out. This one, no amine. This one does meet the requirements, so maybe this guy. So number 3 is one of our contenders. All right, number 4, we already ruled that one out. That's carboxylic acid. Number 5, that one's ruled out because it doesn't have an amine. This one here, ruled out, doesn't have an amine. So we now know the answer is number 3. Cool. So either of those 2 would be an achieve, so take a guess. Okay? All right. So that's what I'm saying. With organic chemistry, they will change around the questions and how they ask it, because each time it is kind of a different setup. But if you have the ability to figure out what function groups you have there, and you know all your reaction schemes and your identification tests, you'll be able to decode the question, which is all we need to be able to do. All right? All right, here's the last one. So they want you to justify your chosen structure for each of the 2 compounds. Your answer should include relate the observations to the functional group identified, identify the types of reactions involved, account for the solubility in terms of length and distance, or sorry, functional group present. So when we look at this marking schedule here, the requirements that it's setting for you is that first one is that wants you to identify one functional group, or you can also identify solubility linked to the stated observations for one compound. So basically pick one compound and tell me, or sorry, pick one of these properties and tell me then what compound it represents. So you could copy this statement down here and go, this represents a carboxylic acid, meaning it must be number 6. Or the reason why it's able to turn the permanganate from purple to brown is because there's an alkene present, which again, we can see in number 6. Or you can refer to the solubility. This one, these are both soluble because they have short carbon chains. So any of those statements would give you an achieve point. So basically, you're already taking what you've done here and writing it down here. All right? So this is an achieve point, and then this is also an achieve point if you do that writing. So you're just basically restating what you know. So just state your process. For example, bubbles with sodium carbonate. Molecule must have a carboxylic acid.
So basically, it's like write one of these bullet points and say it's that, and because it's in number 4, for example,
Yeah.
we know that's
Yeah.
the right answer.
Yeah.
Okay, cool.
Yeah, so there's no... State your process. You guys have done this, because that's the way you figured out 6 and 3. You just need to tell me one of them. Okay? So you have multiple. You have this one, this one, this one, this one, this one, this one. You have 6 ways you can explain it. Okay? And that would be your cheat point. So you have 1, 2, 3, 4. And there's only 4 in the question. Yeah, so there's only 4 cheat points in that question. And when you have the marking schedule here, getting all 4 is an A4. Getting 3 of them, then it's an A3. Okay.
Wait, for just that question or the overall?
Just this question. Because remember, the questions need to add up. Okay. So the overall score that we're looking for on this exam, just so you guys are aware, is, I think it's probably 8. Yeah, it's 8. So that means you have to get at least, you have to pass at least 2 questions at A4. So if you get A4, A4, that adds up to 8. Yeah? If you get A3, 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 that adds up to 9. You still pass. If you get A3, A3, that's 6, and then an N2, that's enough to get 8. So answer everything, even if it's a not achieved answer, those points still count to your overall. And that can be enough to push you over the line. Okay? You could get 2, if you get 2 N2, so N2, N2, A4, that's, again, 8 points. So you can fail 2 questions, pass one of them, then you're fine. Okay?
But is this, sorry, I just feeling that.
Yep.
Is this for like overall?
Overall.
Just to get 8 points for.
8 points overall, anyway.
So basically, if you answer, let's say, for example.
Yeah.
There's 3 questions, so what? If you answer 3, 3, 3, just to be safe.
Yeah, then 3, 3, 3 is 9. You're passed.
Cool.
You can go 4 and fail 1, and you still pass.
Okay.
Yeah. So there's lots of different ways to get to 8. So that's what I'm saying. Answer everything. Don't leave it blank, because even if you get like an N2 or N1, those points help you. Okay? Cool. All right, just mindful of our time, and I don't know how much you want in your brain at once. I'm going to stop the recording so we actually have 3 sets of questions. And you guys can take a little break.